All right, let's go ahead and look at this first problem. So when I first look at this, I'm thinking I want to use the elimination method because I notice I can multiply by 3 here, and I would get 12x, so that when I added the equations together, I would eliminate x. And so that's what I'm thinking, but I'm also noticing that 3 times 5 is 15y, and 3 times 15 is 45. And so this is going to be one of our special cases. And so I'm going to go ahead and use the elimination method. I'm going to multiply this row times 3. So I'll get 12x plus 15y is equal to 45. And then here we have minus 12x minus 15y equals negative 45. So when you add these equations together, everything falls out and you get 0. And what that's telling us is that these are equivalent equations. So what do they have in common? Everything. And so our solution, first of all, we have infinitely many solutions. Infinitely many solutions. However, that's not very specific. In fact, I haven't even given you one exact answer to this system. And so there's another way we can write this out. So both of these equations are equivalent. I'm going to take the easier form, or the easier of the two, the more simplified of the two. Smaller numbers is really all that we're looking at here. And I'm going to solve for x. So we'll get 4x equals negative 5y plus 15. And if we divide by 4, we're going to end up with x is equal to negative 5y plus 15 over 4. So basically, we can write our solutions. Now notice x is in terms of y, and so we can actually write negative 5y plus 15 over 4. That's our x value, and our y value is just y. So we say that our parameter here is y. In other words, we're writing our x and y values in terms of y. I could have solved for y instead, and we could have done the same type of thing, but made everything in terms of x. Generally speaking, we would probably do it using y as our parameter here. All right, let's move on to the next problem. So when I look at this one, and you were asking about how I would choose to solve this, I would like to have a 1x at the upper left-hand corner here. And if like for example, I could divide this equation by negative 4, and I would get the 1 there, but I'd get fractions as well. And so for me, if I didn't have to use matrices, I would want to use the elimination method. In fact, I'm looking at the z's, and I think it would be easiest to eliminate z twice. Remember what our goal is when we solve these using the elimination method. We want to first come up with 2 equations in the same 2 variables. So let's eliminate z twice, and we'll get 2 equations in x and y. So let's go ahead and do that. So I'm going to go ahead and call this equation 1. We got equation 2 and 3 here. And I'm looking at equation 1 and 3. Whoops. So I'm going to go ahead and write equation 1. So that's equation 1. And this is equation 2. Or no, I didn't want to do that. I want to do that with 3. So 3x plus 3y plus z is negative 6. So that's equation 3. And notice our z values are opposite. We have a minus z and a plus z. So when we add these together, we're going to get 3x minus 2x is x. Oh, and actually the y's canceled as well. And so we get x equals negative 2 when we add the equations together. So we were looking to get an equation in y and z, but actually we eliminated z and y, which is fine. It'll actually make it easier to solve this system. So in the first, when I did this work here, I used equations 1 and 3. So now I have to use equation 2. And so what I'm doing, I'm looking at this and I'm thinking, if I multiply the third equation by 2, I would have a minus 2z and a plus 2z, and I could eliminate z. So that's what I'm going to do. So I'm going to do, I'm going to write equation 2. And I'm going to multiply equation 3 by 2. And so 2 times 3x, we're going to get 6x. 2 times 3y, we're going to get 6y. 2 times z, we'll get plus 2z, which is what I needed. And 2 times negative 6 is negative 12. And so here we're going to end up getting a minus 2x. Oh, no, that's a plus 2x. 6y and a minus 2y, that'll be plus 4y, and that's equal to negative 4, negative 12 plus 8. So we'll call this, so over here I should have said this is equation 4, and this will be equation 5. And so I'm going to go ahead and move equation 5 up here. We've got 2x plus 4y equals negative 4. So again, we were expecting here to get two equations in x and y, but we actually were able to solve for x in the first time we added the equations together, and so this makes things a little bit easier. I can just go ahead and substitute negative 2 right here. So this is negative 4 plus 4y equals negative 4. We'll add 4 to both sides. You get 4y equals 0. Well, 4 times 0 would be 0, so y is 0 here. And so what we've done is, first of all, we got our two equations in the same two variables, even though in one case we just had one variable. That was our step 1. And we solved that system, and so now we know, let's see, x is negative 2 and y is 0. That was the second step, solving that. And now a third step is to take one of the original equations and use that to find z, since we don't know z. You can use any of the equations. I'll just go ahead and use the first one here, equation 1. And let's plug in our x value. We have negative 2 times negative 2 minus 3 times 0 minus z equals 4. Negative 2 times negative 2 is 4 minus z equals 4. And we'll subtract 4 on both sides, and we get negative z equals 0. So just multiply both sides by negative 1, you get z is 0. I'm kind of surprised that we got two values of 0. So it's going to be negative 2, 0, 0 is our solution. Now if you had any doubts here about that, I mean, I don't recall having a problem where I had two values turn out to be 0, but it wouldn't be hard to check it. All we have to do is plug in for x, and all of this is going to zero out because y and z are 0. So negative 2 times negative 2 is 4. Negative 4 times negative 2 is 8. And 3 times negative 2 is negative 6. So you can see that this point does solve the system. It is a solution to every equation in the system. And so that is our final answer. All right, I hope that helps.